Alright guys, so 3.4 exponential and logarithmic equations. This is going to be part 1, and part 1 is going to be all about exponential equations, so we're only going to look at half of it right now. And we're going to have 3 ways that we can solve exponential equations. We're going to either create like bases, use natural logs, or then use the definition of logarithms, which is a pretty big part of why we even use them. So first one, if we are going to create like bases, ideally you'll notice that B and B, our two bases, are the same. So if this is the case, then we're going to be able to solve by just setting m equal to n. So the idea is to rewrite each equation using the same base. Now they're not always going to be as simple as seeing them as the same base, and when we do an example you'll see that. You may have to change your base a little bit. Once we do that, we just set m equal to n, which means set the exponents equal, and then we're going to solve for the variable. Now one other thing, when we talk about logs later, you always want to check your answers here. Okay, and it won't be as important for this one, but for the other two it's definitely going to be more important. You have to do that to make sure that we don't have any domain restrictions. We talked about that the other day, don't forget. Okay, so 2 examples here. You'll notice that our bases don't look like they're the same. But if I just rewrite that left side, 16 is the same as 2 to the 4th. So now we've created like bases, and we can say set your exponents equal to each other. So 3x minus 8 equals 4, and solve this like you would solve any other equation. And so we get that x is 4. Okay, if we plug that back in, that'll work, because 2 times 12 minus 8 is 4, and 2 to the 4th is 16, so that checks out. Okay, here, this is another example where actually both of them need to be rewritten. Neither one, you can't make 27 a base of 9, but we can make them both a base of 3. So 27 will be 3 to the 3rd, and then we're going to need to write that x plus 3 in parentheses there. And 9 is going to be 3 squared with your x minus 1 in parentheses there. Now that our bases are the same, we can set our 2 exponents equal to each other and start to solve. Okay, we'll distribute, and we should know how to do this from here. So getting our x's on the same side and bringing that 9 over, we end up with x equals negative 11. Okay, and if we plug that back in, I'm not going to do that to save for time, but if we plug that back in, we would get the same thing again. Okay, so that is creating like bases. Sometimes you'll have to change both sides, both exponential expressions, into the same base. Sometimes you only have to change one. Sometimes they'll already be the same base. Okay, the next type is if we are doing with natural logs. So first thing you're going to do is isolate the exponential expression, and after that you're going to take the natural log of both sides and then simplify using the power rule and solve. And we should even add in a 4th here. Check solutions for, we'll say, domain restrictions. We can also, and have said in the past, extraneous solutions. Alright, so you'll notice here it's different because we can't, one of the reasons we need to use natural logs is because we can't create these as same bases. So we're going to take the natural log of both sides just by writing ln in front. And now, if you remember your power rule, we can take both of these exponents and bring them out front. So x minus 2 needs to be in parentheses times the ln of 5, and that's going to equal 2x plus 3 times the ln of 4. Okay, and now one thing to keep in mind, the natural log of 5 and the natural log of 4 are just some numbers. So if you plug those into your calculator, we're going to get 1.609 for 5. So I'm just going to write 1.6 and then x minus 2 in parentheses. And if we did the natural log of 4, we would get 1.38. So we'll say 1.4 times 2x plus 3. And then we should know how to solve that from there. We're going to distribute to both sides, get all our variables on one side. I'll let you guys do that on your own, just again so we can save time in the video. Okay, the big point there is to take the natural log of both sides, and then you're going to do power rule and bring your exponents out front. Okay, and then we can distribute numbers. That'll simplify things for us. Okay, the last way is definition of log. So we're going to start the same way, isolate the exponential expressions, and then we're going to change into log form. So remember, everything that is exponential form has an equivalent log form. So we're going to change from our exponential form to our log form, and then we're going to solve for the variable. And again, same idea on step 4 here. Check your solution. Okay. So moving on, you'll notice here we can change this into log form then, because remember that helps us solve for our variable. So we would say log base 4 of 15 equals x, and we already have it solved there. We can do our change of base formula to figure out what that is as a decimal. Okay, so this one already had, the first one already had our exponential expression isolated. You'll notice on the second one it's not isolated yet. So we need to start by adding 3 to both sides. And so that's going to give us 240 over there. And then we still need to get the e to the 0.6x by itself. So we divide by 40, and that's going to give us 6 on this side. Okay, now we can change into our log form. So we're going to say, and I'm going to write this as ln, because that would be log base e of 6 equals 0.6x. And so to get x by itself, we're going to divide by 6. So if you took the natural log of 6, divide by 0.6, and divided by 0.6, that would give you some decimal approximation. Okay, so the way that we are going to, don't need that one again. The way that we are going to decide which one to use, the easiest one to decide to use is pretty much our definition of logarithms. You'll notice on those examples there was only one exponent with the variable. So when that's the case, it's easiest just to use the logarithms one. Okay, when we have multiple exponents or multiple exponential expressions with a variable, we're going to use one of these two. If you can create like bases and solve that way. Just set your exponential expressions equal to each other, your exponents equal to each other. If you cannot write them as like bases, like the one example we had a base of 5 with something equals 4 with some exponent. Since we couldn't create like bases, we're going to use natural logs. Okay, so that is your 3 ways: like bases, natural logs, or definitional logs, and when you would want to try to use each. If you can use definitional logs, and we practice going back and forth between exponential form and log form, that's the best time to use that one. The other ones, when you cannot, or when you have variables in multiple exponents, that's when we would need to use those. Okay, we'll see you next time.